with a very beautiful example, and this example is from mean value theorem, and it is also very good because I shall ask all of you to remember this result which I'm going to tell you right now, and in no book you are going to find it. Okay, so please concentrate. The question is, it's a very important question, and since the mode of the examination is online, so this question may be set. So the question is, let f be a function, let f be a function defined from AB to R such that number one, f is continuous in AB. Number two, f is differentiable in AB. Number three, FA is equal to FB. Does it imply there exists a point C such that f dash C is equal to 0, C belonging to R? Now this question, I can understand what you are thinking of right now. Probably you are thinking of Rolle's theorem. Okay, and probably you are thinking that why sir is asking this question because it has already been done. But if you carefully observe, you will find that a particular condition from the Rolle's theorem has been relaxed. In Rolle's theorem, actually f was continuous in the closed interval AB, but here I have broken the continuity in the lower and at the lower and the upper limits. There the function is not continuous at the lower. We cannot say anything about the continuity of the function at lower and the upper limits. Okay, so that condition has been relaxed. The question is, if I relax this condition from Rolle's theorem, is it Rolle's theorem will be applicable or not? That is the question. So that is a very beautiful question, and you have to know this answer, because probably some people are thinking that in defining Rolle's theorem, continuity is checked in the closed interval, but differentiability is checked in the open interval. Why is it so? So this example will tell you that this has to be okay. So continuity has to be checked at the lower limits and the upper limits also. So the answer is, the question is, does it imply that there exists a point C such that f dash C equal to 0? Answer is no. The answer is no. There doesn't exist any such point in C so that this happens. There does not exist any such point C in AB, C belonging to R, so that f dash C is equal to 0. Now, if I am saying so, then I have to produce one counter example. So, for example, let us consider the following function. Let us consider the following function. And you will write quickly because I'll quickly go through go to the next page. Okay. Let us consider the following function, and the function is defined as fx is equal to x x lies between 0 and 1. So I have not included the point upper limit 1 over here, and 0 when x equal to 1. This is the function, very simple function, but very beautiful function. So let us draw the diagram of this function. Okay, and the curve, if this is the origin, the curve is like, say, this is the straight line, and this is the point origin, and that is having the x coordinate 0, and this is the point, say, 1 0. Okay, this is the point A, which is 1 comma 0, and I'm putting dot over here and a break like this. Okay, so there is a discontinuity, because at 1 it is discontinuous, and at 1 the function is having value 0. So this is the function we are having. Okay, now you see that this function fx is obviously differentiable in open interval 0 1, continuous in open interval 0 1, and not only this, f0 equal to 0, and by definition f1 is equal to 0 also. So all the conditions here are being satisfied by this function, but you will not be able to find any point where the tangent will to the point will be parallel to x-axis. So there does not exist there does not exist any point in 0 1 where tangent to the point is parallel to x-axis, which actually justifies that f dash c equal to is not equal to 0, because otherwise this could have happened. Okay, so therefore there are some functions where if the function is not continuous in the boundary points, then the Rolle's theorems are not satisfied. So to satisfy Rolle's theorem, you have to check the continuity of the function at the boundary points. I will ask all of you, always remember this result. This is also very important for GATE examination or for any competitive examination where a little bit of mathematics is required. Okay. And if you want to forget it, then it is up to you. Okay. So I'm not pressurizing you to remember this. Now, next, I started with Rolle's theorem because I was actually supposed to tell you this. Otherwise, my discussion on mean value theorem would have remained incomplete. And one more topic of mean value theorem is still there, which I have not talked about. It is called Cauchys mean value theorem. Cauchys mean value theorem. It is not Cauchy. Although some people like to call it as Cauchy. Even I do not know what is its actual pronunciation, but my teacher used to say it Cauchy. So therefore, I'm just following his path. So the statement goes like this: let f and g be continuous, f and g be continuous on AB and differentiable on AB and differentiable on AB, and assume that g dash x is not equal to 0 for all in for all x in AB. Then there exists a point C in AB such that f of B minus f of A by G of B minus G of A, that is equal to f dash C by G dash C. This is the statement of the Cauchys theorem, and Cauchys theorem statement actually comes in the examination. In examination also, they may ask you, if it is an online examination, they may ask you, say for example, which of the following options where part is part of the Cauchys mean value theorem, which has not been shown. I mean, in various ways, they may make you confused to know whether you know the Cauchys mean value theorem in its entirety. So the first two parts of Cauchys mean value theorem are just like the mean value theorems: continuity in the closed interval and differentiability in the open interval. And g dash x should not be equal to 0 for all x in AB, because otherwise this could have been undefined. Okay, 0 could have come out in the denominator. So if this is not so, then there exists point C in AB such that this happens. Okay, so this is the formula of Cauchy's mean value theorem. And let me show you one example, so then you will understand what is happening. So for example, let us consider two functions. Let us consider two functions. Fx is equal to mod x in x in sorry in this interval, and gx is equal to sine x in this interval. Both are defined in the same interval. Okay, now you see that fx is actually, the fx is continuous. Fx is continuous in mod x function is continuous function in the closed interval 0 pi by 2. Okay, and because you know mod x function, that it looks like it's inverted v, v. So fx is continuous from in this closed interval 0 pi by 2, and the trigonometric sine function is also continuous in the closed interval 0 pi by 2. And also we know from our earlier experience that mod x is not differentiable at 0. So fx is equal to mod x is differentiable in the open interval 0 pi by 2. And obviously sine x is differentiable in this interval also. Sine x is differentiable. Sine x is our gx, so it is differentiable in this open interval also, 0 pi by 2. Okay, and we know that g dash x is equal to actually cos x, which is not 0 for any x in the open interval 0 pi by 2. If you take pi by 2, then cos pi by 2 is 0, but I'm taking open interval. So therefore, you have to be very careful. If you write a closed interval over here, that will not hold good. So each line, each point written in this particular statement are very important, and you cannot just neglect it. So therefore, we all these conditions are satisfied over here. Now we are going to according to the Cauchys theorem, according to Cauchys theorem, there must exist a point C in 0 pi by 2, because the open interval is taken, so that okay, I'm writing over here because probably you are copying. FB, I mean FB means mod x at x equal to pi by 2. Here your A is 0 and here your B is pi by 2. Remember, minus mod x at x equal to 0 by sine x at x equal to pi by 2, sine x at x equal to 0. Okay, this should be equal to some point C must exist in 0 pi by 2, so that we must have this f dash C and g dash C. First of all, I will try to find out this left hand side, and then I will try to find out what that point C could be. First of all, I will try to find out the value which is coming on the left hand side, and then I will try to find out what this value could be. Now, can I think you have copied it, and I can easily move on to the next page. Then if you have not copied, you take a screenshot, or otherwise after I finish the problem, I'll again come back to this particular page so that you can complete the incomplete portions that you have not copied yet. Okay, so remember, I'm continuing from this point. Okay, so I'm considering the left hand side, means this part. Okay, now LHS, which is mod x at x equal to pi by 2 minus mod x at x equal to 0 sine x at x equal to pi by 2 minus sine x at x equal to 0. This is equal to, so put the values, mod pi by 2, mod 0, and that is sine pi by 2 and sine 0, and mod pi by 2 is pi by 2, and that is 1, so answer is pi by 2. Okay, left hand side is pi by 2. Now, by Cauchy's mean value theorem, we must have f dash c by g dash c is equal to pi by 2, which is your RHS. Okay, so from there I will try to find out what f dash c is, I mean what c is. Okay, so let us write here, in the limit, in the interval 0 pi by 2 mod x equal to x. Why? Because we know that since mod x equal to x when x greater than 0, 0 when x equal to 0, minus x when x less than 0. So f dash c means d dx of mod x at x equal to c and that would be d dx of sine x at x equal to c. This should be equal to pi by 2, and therefore this should be d dx of x at x equal to c, and this should be d dx of sine x at x equal to c, and this should be equal to pi by 2, and d dx of x is 1 and sine x is cos x at x equal to c. This should be pi by 2, so that cos of c, this is 2 by pi, and the point for which this is going to happen is cos inverse 2 by pi. So that is your answer. That is your answer. Some people are some students are sending me some problems to for me to solve. They are stuck in problems. Some people are sending problems to me from this linear algebra. Some are sending problems to me from calculus. Please do not send any problem this week, because this week I'm extremely busy. I have to prepare your question paper of the internal examination CA3, and some 2 other question papers I must prepare. Mark submission has started. This week, if you are facing any defects, keep it with you. You can send me WhatsApp. I will try to help you, but not this week. Please don't expect anything from me this week because I'm extremely busy. Sorry, because I have to prepare your marks. So this is the thing. So this is the point. So this question, although I have written in this manner, it can be asked in this way. These are the 2 functions. Check whether Cauchy's mean value theorem is satisfied or not, and if it is satisfied, find the point C at which it is being satisfied. So you have to do it in the way. So this problem is also a very good problem. Now I am going to move on to another topic, which is probably the topic which you have probably done during the competitive examination preparation. It's called L'Hospital's rule. Some people say it's L'Hospital rule. Whatever, there are various names. I do not know what is the pronunciation of that. Now you may ask me one question, whether sir, you have started with mean value theorem and Cauchy's mean value theorem has done. So, and suddenly you are going to L'Hospital's rules. So is there any connection between this mean value theorems and L'Hospital's rules? So obviously there is a connection, because the note which I have sent you, this section 6.3 of this of Bartlett-Sherbert, you will find that in this section, under section 6.3, L'Hospital's rule, Cauchy's mean value theorem has been stated. To prove some results of L'Hospital's rules, actually this mean value theorem is required. Okay, so they are interconnected to one another. This much I can say right now. You know that L'Hospital's rule deals with the limit where the function is taking this 0 by 0, and this form is called indeterminate form. Indeterminate form. And we deal with this, we actually deal with these functions. We know what to do. You also know what to do with these functions, but actually what we do not analyze before we use the function, before we apply the rule, we do not analyze the thing. So this analysis is actually very important. And 0 by 0 is not only the indeterminate form, some other indeterminate forms are there, which is infinity by infinity, then 0 to infinity, 1 to the power infinity, 0, infinity to the power 0, 0 to the power 0, infinity minus infinity. All these are actually indeterminate forms where L'Hospital's rule can be used. But we shall discuss 0 by 0 and infinity by infinity, and other results, means this can be brought into this particular category, 0 by 0 or infinity by 0. So anyways, I'm going to I'm going to make you look at L'Hospital's rule and again in from analytical perspective. So first of all, let's start with a theorem. The theorem states that let f and g be defined, f and g be defined on AB. F and G be defined on AB. Let FA is equal to GA is equal to 0. Probably from my past two examples, probably you have understood why these statements are very important. And you have to be very careful not to miss any point from the statement. So let F and G be defined on AB, and let F and GA are both 0, and let Gx is not equal to 0 for A less than X less than B. Okay, if F and G are differentiable, if F and G are differentiable at A, if F and G are differentiable at A, and if G dash A not equal to, this is G dash A not equal to 0, then the limit of F by G at A exists and is equal to F dash A by G dash A. Thus limit x tends to A plus Fx by Gx is equal to F dash A by G dash A. When you prepare for the competitive examination, you are only told about this. And I haven't taken the coaching of any competitive examination ever, but probably if I'm wrong, later you rectify me. I'm pretty much sure that they do not discuss all these things in its entirety. They just discuss this. Okay, if you have this kind of form, this just check whether fx is 0 and gx is 0, and if this is true, it is 0 by 0 indeterminate form, and if it is so, then you can take derivatives until derivative exists and 0 vanishes from this denominator. You will get your result. That much is told to you. Okay, but you have to be very careful, because you have to take these functions, only those functions which are defined in AB. Say for example, if I take a function, say if I take f of x 1 by x in 0 1 closed interval 0 1, and if I give you a problem similar, so you'll see that first of all, this L'Hospital's rule will not be applicable to the function, because the function is not defined at x equal to 0. So I'm not going to apply any L'Hospital's rule to such problem. I have to check whether the functions are defined or not at all. Then I have to check this condition. This is a very vital condition. This condition is very vital condition. So I shall quickly prove this L'Hospital's rule. Srimanti raised her hand. If you want to say anything, write in the chat box. Or you can unmute yourself. Okay, you write in the chat box. What do you want to say? Okay. Okay, something she has written. Okay, you ask, you write. I'm starting the proof. Okay, I'm writing the proof. Since FA is equal to GA is equal to 0, we can write the quotient Oh, you want to ask why 1 to the power infinity is indefinite form. Try to think why it is not. That you discuss with me later on, not now. 1 to the power infinity, infinity to the power 0, these are all the indeterminate forms. Why 1 to the power infinity is indeterminate? This is very, I mean, question is very good, but if I try to ask talk about this right now, so it will just kill my later we can discuss. Okay, later, it is, keep it with you, one day we'll discuss about this. Okay, so since fa equal to ga equal to 0, we can write the quotient fx by gx for this, as we can write fx by gx in this way. We can write it as fx minus fa by gx minus ga. Why is it so? Because since fa and ga are 0, so fx minus 0 is same as fx, and gx minus 0 is same as gx. And we can divide both the numerators and denominator by x minus a. It will not change the structure. So we can write it in this manner. Okay. And then limit x tends to a plus fx by gx, that would be equal to limit x tends to a plus this thing, this item. So it would be fx minus fa by x minus a, and gx minus ga by x minus a. Okay, I do not have any space over here, so I'm going to the next page. So we can write it limit x tends to a plus fx by gx. This can be written as limit x tends to a plus fx minus fa by x minus a, and limit x tends to a plus gx minus ga by x minus a. And what is this? This is your f dash a, and that is your g dash a. So you see, this has proved the given result. Probably you can think that why I'm taking a plus, because a plus, you know, it is the limit approaching to the x approaching to a from the right hand side. So it is a right hand limit. The results, these results will also hold for left hand limit also, or any limit. Okay, so you can do the similar thing for x tends to a minus also. Now this condition fa equal to ga is equal to 0, this condition is, why is it so vital? Let us try to discuss this. Why this condition fa equal to ga is equal to 0 is vital. Okay, so quickly I'm saying that you take fx equal to x plus 17 and gx is equal to 2x plus 3, x belonging to R. Now you see f0 is equal to 17, which is not equal to 0, and g0 is equal to 3, which is not equal to 0. So f0 and g0 is not being satisfied. If you consider 0 to be the lower limit, say for example, I am taking 0 to pi by 2. This is my interval. So in this case, it is not happening. So limit x tends to 0 fx by gx. You can put your attendance quickly in the chat box, otherwise time is running out. So this can be written as, you see, this value is 17 by 3, and f dash 0 by g dash 0. Write your roll numbers, student IDs in the chat box. Chat box is open. F dash 0 and g dash 0 is actually half. You see, fx is equal to 1 and f dash x is equal to 1 and g dash x is equal to 2. So f dash 0 is equal to 1 and g dash 0 equal to 2, and therefore you see that this not being satisfied. Here limit x tends to 0 fx by gx is actually not equal to f dash 0 by g dash 0. Why is it so? Because this condition was getting violated over here. So this condition is also very vital. Write your student IDs in the chat box. Why aren't you writing? Are you listening to me? Srimanta, can you listen to me? Hello? Hello?